Okay, we're going to look now at the addition rule for probability. And what we need to take into account is whether or not there are any elements in the intersecting set. So if we're looking at 2 or 3 or 4, whatever number of elements, if we want to find out what the probabilities of either A or B or C happening, then we add all the probabilities up. And if there are no intersecting elements, i.e. the events are mutually exclusive, they can't both happen, they can't fall into both sets, then all we have to do is add up the probabilities. Do an example in a minute. If there is an intersecting area, yes, we still add up the probabilities, but we need to then subtract what is intersecting. Have a look at an example here. Numbers from 1 to 12. Set A are the factors of 2 and set B are the factors of 3. So if we have a look here at a Venn diagram where this is set A here and this is set B here, and then we frame it. So we go through the numbers from 1 to 12. Number 1 is going to sit outside, it's not a factor of 2 or 3. Number 2 is going to sit in here. 3 is going to sit in here. 4 is going to sit in here. 5 is going to sit outside. Now 6 sits in both, doesn't it? It's a factor of 2 and 3, so 6 goes in there. 7, neither. 8 in here, only a factor of 2. 9 goes in here. And 10 goes in here. 11 sits outside. And 12 will be another intersecting. So what we end up with here is, if we wanted to look at the numbers in the set A union B, then because they're not mutually exclusive, we have to take the numbers in set A, add the numbers in set B, then subtract the numbers that are in the middle, A intersection B. Because if we add up the numbers in A, then we're going to go 1, 2, 3, 4, 5, 6. If we add up the numbers in B, we're going to go 1, 2, 3, 4. But there aren't 10 elements here. There's only 1, 2, 3, 4, 5, 6, 7, 8. We need to subtract the 2 that are in the middle. So it's obvious here, but it's not always quite so obvious. 6 plus 4 is 10, minus 2 is 8. So the number in the union of A and B, sum A and B, but subtract what's in the middle. And it's not a massive issue if there's no intersecting elements. You just subtract 0. So you should always look for those intersecting elements to subtract once you've added up your various numbers from other sets. Okay, so if we wanted to look then for the probability, if a number is chosen at random that it's divisible by 2, then you'd say, right, well, there's 1, 2, 3, 4, 5, 6 that are divisible by 2 out of 12. Half. If it was the probability that it was divisible by 2 and 3, it would be those two, so 2 out of 12. 2 or 3, so the probability is divisible by 2 or 3. Now this is the same as A union B. It would be 2 or 3, so you'd add up the 2 and the 3, and then you'd subtract you'd subtract the 2 in the middle. So you'd go 6 plus 4 minus 2 is 8 over 12, which is 2/3. Okay, let's go to another example here. This is from the textbook. A card is selected from a pack of 52 playing cards. So there's 4 suits of 13 in each. Let A be the event the card is a diamond, and B be the event the card is a jack. Okay, so that's the setup. Now we're obviously going to have some stuff in the middle, aren't we? So if you wanted to set up a Venn diagram for this, we could. This is A and this is B, and we've got A is the card's a diamond, so A's got a fair few in it. It's got the 2 of diamonds, 3 diamonds, 4, 5, 6, 7, 8, 9. Is there a 10 of diamonds? And then there's a jack. B's the event the card is a jack, so it's a jack of diamonds. Then there's the queen, king, and ace. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 cards in the A set. Now in the B set, we've got the other 3 jacks, haven't we? We've got the jack of hearts, the jack of clubs, and the jack of spades. So that's how it would look. And so if we're then looking for The number in set A, is 13, as we just discussed. The number in set B, the number of elements in set B is 1, 2, 3, 4. The number of elements in A intersection B is just the 1. Okay, so then we want to maybe look down at the probability of A occurring. The probability of A occurring will be 13. So 3, 6, 9, 12, 13 out of a total of, sorry, just got interrupted, 13 out of a total of 52 playing cards, so it's 1 in 4. So then we look at the probability that it's not A. Well, the probability that A is 1/4, the probability that it's not A will be 3/4. Remember, A and not A are complementary events. They add up to 1. Their probabilities add up to 1. So complementary events are like a head and a tail when you toss a coin. They're complementary events to each other because together they must happen. All right, so probability of not A, the probability of A intersection B will equal, there's only 1 in there, so that's 1 out of 52. The probability of A union B, either A or B. So this is where we take A into account. We take 13 over 52. We add B, which is 4 over 52. But then we subtract the 1 in the middle, 1 over 52. So we get 16 over 52, which is 8 over 26, or 4 in 13. All right, now last example here, we're just going to look at two events A and B. Probability of A is 0.4, and the probability of B is 0.8, and the probability of their union is 0.65. Remember that their probability of A union B will equal the probability of A plus the probability of B minus the probability of A intersection B. Our first task here is to find A, is to find the probability of section B. So what we'll do is we'll use this 0.65 equals probability of A is 0.4, probability of B is 0.8, and so our probability of A intersection B must be equal to 1.2 minus 0.65. So therefore the probability of A intersection B is equal to 1.2 minus 0.65, which is equal to 0.55. Okay, so we use that property, and then for B, we're asked to find the probability of A complement intersection B complement. Now this is an interesting one. The right, if we have a look at the Venn diagram situation here of A and B, now A complement is everything outside A, B complement is everything outside B, so this will be equal to everything outside here. Right, so that's what that is. The A complement intersection B complement is all this around here. Now we know what A union B is. It's A union B is 0. Here it is 0.65. So this is 0.65 in here. So outside that must be 0.35. So that was 1 minus 0.65. Okay, that'll do us. Exercise 8C is there for the taking, and we'll do that when we meet next in class. Cheers.